Good evening. For today's discussion post, I have elected to change things up. Instead of actually typing out a response, I decided to present one. I thought it'd be an interesting twist, and I don't recall anywhere in the syllabus saying where Professor Cabbage... I'm still not used to saying his name. Where he actually said, no, you can't do this. No, there's no specific format, so why not? So the question is, do we have a population problem? Not really. This presentation is being presented by Paul Ayton. You are listening to Paul Ayton's voice, and this is for the class EIU 4102-600. So let's begin. Some basic facts. The global land area of the planet Earth consists of approximately 196 million square miles, which is equal to 510 million square kilometers. For the purpose of this video, since I am a mathematician, I prefer kilometers. I don't know why. I just do. It's the units of tens, probably. And also for the purposes of this video, we're going to assume a low end of global land area. Using that, it will be around 440 million square kilometers. Now, at present, the global population, as you all may know, is approximately 7.5 billion people, and we are growing at an average of 80 million people per year. Thus, in 10 years, we should have an additional 800 million people to our current population, leaving us at approximately 8.3 billion people. For the rest of the video, we will be using a number of 7.5 billion people. Continuing with some basic facts. According to the Food Agriculture Organization for the United Nations, and also from the Indian Institute of Science in Bangalore, the minimum land necessary for sustainable food security is 0.5 hectare per person. Now, if you look at what hectares are, they are simply 100 square airs. What's an air? It's approximately 100 square meters. Converting that to math, 0.5 hectares is equal to 0.005 square kilometers, or approximately 1.2 acres. If any of those numbers sound familiar, good for you. You were paying attention in high school. Percentage of farmable land on planet Earth is approximately 37.7% to 10.6%. Now, these numbers vary so much in response to the amount of farmable land as compared to arable land. I will let you research into the differences. However, for the purpose of this video, we're going to assume a low end of 10% of total land on planet Earth as being farmable. And finally, we're going to assume an average home space for 4 to 6 people, primarily 4 people, to be about 1,500 square feet, or approximately 0.1393546 square kilometers. Here's where the math comes in. Of course, housing space is going to be the amount of space needed for 4 people, being examined over the current population, which is currently which is currently, as you can see the equation, we only need, for 4 people living per 15 square feet, 2,600,200. Sorry, I am tired right now. Sorry for any slips in verbiage. 261,289,875 square kilometers. That's housing space for the current world population. Farming space is the current world population. Once again, taking the 0.005 kilometers squared, or 1.2 acres, and multiplying those together to find that we only need, for the current population, approximately 73,500,000 square kilometers for total farming space. Now, proper farmland is, as I said, 37.7% to 10.6% of the world's total land area. So with a low end of land area, at 10%, we're looking at approximately 44 million square kilometers. And at 10%, again, we're still left with 6,530,000 square kilometers left over at that point. And at 30% of a low end of total land area, we're dealing with 132 million square kilometers, which is approximately 3 times 10%. So anything else that I'm going to say, if you want to know the numbers at 30%, it's going to be dilated by some factor of 3. So the conclusion is, we don't have a population problem, even at the aforementioned 10%. 6,530,000 square kilometers is enough land to account for an additional an additional 1,306,000,000 people. That would take us a little over 15 years to account for, and does not accommodate for the 30% of land used for farming, or the full 37.7% of land. So even on a low end, we have plenty of space to account for everyone, giving us plenty of time to make adjustments. So if there becomes a population problem, we need to take the 15 years and multiply it by about 3, 45 years, 45 to 50 years for a nice range. We have 45 to 50 years to come up with a solution, invent new technology, new avenues for housing, new avenues for agricultural development. And if in that time we do not fix the issues that we have, then we might start having a population problem. But again, it won't be for another 45 to 50 years before we actually have that kind of problem. Now there are other issues at the time to take into account, such as CO2 emissions, higher population. I recall Bill Nye stating that the average American is responsible for 16 metric tons of CO2 pollution per year. All right, fair enough. Supposing the population is to rise, if you look back at the first discussion of week 2, where we discussed man-made global warming, if you find my post, I make a very strong argument that CO2 emissions are not something we have to worry about, as on the low end of deforestation, all the trees in Canada, on a low end of deforestation, on the low end of total area in Canada that contains forest, Canada alone accounts for over 60% of the world's CO2 scrubbing. If we include mainland America, mainland United States, that amount is effectively doubled, almost tripled. So CO2 emissions, and I know that will be a popular argument, is debunked. But that's just my 2 cents. Don't bother listening to me less than 50 times, because that will just equal $1. And as we all know, $1 won't buy anything. So, ladies and gentlemen, please have a nice day, nice evening, nice morning, whatever. If you're actually listening to this, I am so sorry. I'm surprised you actually stomached the entire presentation. As for my sources, here we go. These will be available on the discussion post, along with the link to this video. So once again, have a nice day, and take care.